Good morning, students. Today we will do the next portion of the chapter, heat. Students, in the last class we have already learned about one way of heat transfer, that is conduction, and about the good conductors and bad conductors of heat. Today we will learn how to use those good conductors and bad conductors in our daily life. First of all, you can see the picture of cooking utensils. So, cooking utensils are made up of good conductors as well as bad conductors. The main pan of the cooking utensils are actually made up of good conductors, right? Because when you place the pan over the oven, what will happen? When we switch on the oven or the gas burner, what will happen? The pan will get heated and the heat will be transferred throughout the pan due to conduction, as the cooking pan is made up of good conductors. Now if we place any food items, any water to boil, what will happen? It will be cooked or the water will start to boil. Now you can see the handle of the cooking utensils are generally made up of bad conductors of heat or insulator, because it doesn't conduct heat very well. If it conducts heat very well, when the pan of the cooking utensils will get heated, the handle will also get heated and we cannot hold the handle for longer time, or we cannot hold the handle and we can pour the food into another container. We can't hold it properly. So it should be made up of bad conductor. The handle should be made up of bad conductor or insulator so that we can hold the handle properly and we can use the cooking utensils very easily while cooking, or we can handle the cooking utensils while cooking. Now another application you can see, woolen cloths. We know during winter season we use woolen cloths to keep us warm. Not only woolen cloths, blankets, quilts in winter we use to keep us, here also you can see gloves we use to keep us warm in winter season. What happens that in this woolen cloths air is trapped. We know, students, wool is a bad conductor of heat, as well as air is trapped in the gaps of the wool. Air is also a bad conductor of heat. So what happens, students, when we wear this type of woolen gloves, so heat energy from our body cannot escape out due to the process of conduction to outside surroundings. That's why these woolen cloths make us warm during winter season. So here the main thing is air is trapped between the gaps of the wools, and air is a bad conductor of heat. That air doesn't allow the heat energy from our body to escape out in the surroundings. Okay, students? Now igloos. In extremely cold places, people use this or make these types of houses and they stay in these houses. These houses are actually made up of snow, and these houses are known as igloos. Why, students, they make houses made up of snow? Here, students, what happens, you can see the house is made up of some snow blocks. In these snow blocks, actually what happens, air is trapped between the crystals. So that air behaves as bad conductor or insulator of heat. It prevents the heat to escape out from inside. Okay, that's why if people stays inside those houses, they feel comfortable. Now students, I will discuss about another way of heat transfer, that is convection. In generally liquids and gases, convection takes place. So heat is transferred generally due to the process of convection. Okay students, so what is convection? The process of heat transfer in a material due to the actual movement of the molecules of materials is called convection. Now students, I will tell you how heat is transferred in liquids and gases. Then you will clearly understand about the process of heat transfer and why in definition it is said that this heat transfer takes place due to the actual movement of molecules in materials. So now we will study the transfer of heat in a liquid. Here you can see students, one container is kept over the oven and the gas burner is on. So what happens first of all, as a liquid is kept in that container, the bottom part of the container will get heated at first. So the liquid at the bottom part of the container will get heated. As soon as the liquid will get heated, those liquid will rise up. Why? Because those liquids are warmer than the other liquids and they are less dense, and those liquids will rise up. And the cold liquids from the beside the container will come to take its place. So you can see in this way a circulation is set up. So here you can see the same thing happens. Water starts to boil, which is present in the bottom of the container first. Those hot water rises up and the cooler water sinks down. So a circulation, you can see the circles are drawn. Circulation is set up and this is known as convection current. So here the heat is transferred throughout the whole water, throughout any other liquid if we keep it in the container, by the process convection, and there is a constant circulation of cold and hot streams of water, that is known as convection current. Okay students, now we will observe the heat transfer in gases. For this we need to do another activity. Here we will take one rectangular box. Okay students, and here you can see in this box two holes are there. One is on the left side, another one is on the right side. And we will place a candle under one of the holes. Here below the left hole, candle is there. And there is another hole above which another chimney is there, and there we will place some incense sticks of any paper which is burning like this. So what we can observe students, the smoke which is coming from the incense stick or the burning paper entering the box through the right hole and it is coming out through the left hole. Why students? Because the air above the candle, as the candle is burning, becomes warm, and we know that it will become less dense. So the air rises up and escapes out of the hole above the candle, and the cool air from the other hole rushes into takes its place. The smoke of the incense stick or the paper gets sucked into the box along with the cool air. The flow of warm and cool air sets up a convection current. So this process is happening due to the process convection. Okay students, hope you have understood this. Here actually the circulation is like this. Now examples of convection current in nature. The most common example that I can give you students, land breeze and sea breezes. So what is sea breeze? Here you can see students, during daytime we know due to the sun rays are coming to our earth, land and sea gets heated. But land takes much less time to get heated than sea. So what happens students? Air above the land gets heated up faster than the air above the sea. So what happens students? Air above the land gets heated up and they become less dense, and those air rise up. You can see with the red arrow it is showing warm air is going up. Now cool air from sea comes to take its place on the land. That's why one convection current is set up, and due to the process of convection, cool air from sea comes to the land, towards the land, and which is known as sea breeze. Okay students? Now land breeze. During night, what happens? Throughout the whole day, land and sea are getting heated, but we know land gets heated faster as well as it cools down faster. But sea gets heated up after a long time, or the air above the sea also takes time to get heated up, and those air also take time to get cooled down. So during night what happens students? The air above the sea is warmer than the air above the land. So those warm air becomes less dense and rises up. And cool air from the land comes to take that place. That's why air from the land flows towards the sea. That is known as land breeze. So this circulation, what you can see, the warm air rises up from the sea and cold air is coming from land towards the sea. This is the process due to convection. And the circulation is known as convection current. Hope you have understood students. So up to this you will learn from your book. Thank you.